In this example, we are asked to evaluate the definite integral from 0 to 2 of the function x over the quantity x plus 1 cubed. Now, looking at this integrand, my intuition here is that I'm seeing this x plus 1 being cubed, i.e. inside a function in the denominator. And to me, that's an indication that a u substitution may be a good approach with u equal x plus 1. So we're starting off with the definite integral in terms of x, applying a u substitution. We want to write down an equivalent definite integral solely in terms of the variable u. So to get this integrand in terms of u, we note du is dx. So the dx is going to become du. And we have this leftover x in the numerator. Well, to express that in terms of u, we go back to our u substitution. It gives the relationship between the two variables. X is equal to u minus 1. So we can now rewrite this integrand solely in terms of the variable u. So the x in the numerator is u minus 1. The bottom becomes u cubed, and the dx simply becomes du. But know what we need to do here. It's a definite integral. So those original limits of integration are in terms of the variable x. We need to put new limits of integration in terms of the variable u. So going back to our substitution, we note that if x is equal to 0, the original lower limit, then u is 0 plus 1, which equals 1. So our new lower limit of integration is u equals 1. The old upper limit is 2, which tells us u is equal to 2 plus 1, which is 3. So we now have an equivalent definite integral solely in terms of u that we need to evaluate. Before anti-differentiating, a little bit of algebra here goes a long way, and note that ideally we can get this solely in terms of powers of u. So we can break up a fraction over addition or subtraction in the numerator. So this becomes u over u cubed, or u raised to the power minus 2, minus 1 over u cubed. So u to the minus 3. And once we get it solely expressed in terms of powers of u, we now have a simple integral to evaluate. So the antiderivative of u to the minus 2 is minus 1 over u. The antiderivative of u to the minus 3 is going to be minus 1/2 u to the minus 2. So minus a minus makes this a plus 1/2 u to the minus 2. And we need to evaluate from 1 to 3. So we plug in u equals 3, so minus 1/3 plus 1/2 times 1/9, and then we subtract away what we get when we plug in 1. So minus 1 plus 1/2, so minus, and then doing just a touch of algebra here, this becomes the number 2/9. So remember, when evaluating a definite integral with a u substitution, you do need to change your limits of integration. But on the plus side, once you change your limits of integration, what you're going to end up with here is an equivalent definite integral in terms of u, and you simply evaluate. There's no need to resubstitute or ever write back in terms of the variable x.